October 3, 1975. Naval Station Norfolk, Virginia. The USS Nimitz, designated CVN-68, was commissioned into service with the United States Navy. The ceremony drew thousands of spectators, naval officers from allied nations, and senior Pentagon officials. The ship towering above them represented something unprecedented in naval history. At 1,092 feet in length, with a flight deck spanning 4.5 acres, displacing over 100,000 tons fully loaded, the Nimitz was the largest warship ever constructed. But the truly revolutionary capability lay hidden deep within the hull. Two A4W nuclear reactors, designed by Westinghouse, generated heat to produce steam that drove 4 massive turbines connected to 4 propeller shafts. The reactors, using highly enriched uranium fuel, could operate for more than 25 years without refueling. This meant the USS Nimitz possessed effectively unlimited range, constrained only by the endurance of the crew and the capacity to store aviation fuel, ordnance, and provisions. The ship could steam at maximum speed for years if required, crossing oceans repeatedly, positioning anywhere in the world, all without ever pulling alongside a tanker for fuel. Soviet naval intelligence officers who analyzed the Nimitz's capabilities submitted reports to Moscow that bordered on disbelief. A single American aircraft carrier possessed more sustained operational capability than the entire Soviet carrier program combined. The reports concluded with an assessment that would haunt Soviet naval planning for the remainder of the Cold War. The Americans have deployed a floating city capable of operating worldwide for decades without returning to port. We cannot match this capability with current technology or foreseeable resources. The Nimitz represented the culmination of American investment in nuclear propulsion and power projection naval doctrine. The Soviet Union, despite decades of effort and billions of rubles invested in naval development, would never deploy an equivalent capability. The gap between American and Soviet carrier operations would remain throughout the Cold War, a testament to choices made decades earlier about technology, doctrine, and industrial priorities. To understand the magnitude of Soviet disadvantage in carrier operations, you need to understand the trajectory of Soviet carrier development and the limitations that constrained their program throughout the Cold War period. The Soviet Navy had experimented with aircraft carriers since the late 1960s, but their approach differed fundamentally from American carrier doctrine. The first Soviet carriers, the Moskva-class vessels commissioned in 1967 and 1968, weren't true aircraft carriers at all. They displaced approximately 15,000 tons and operated only helicopters, primarily for anti-submarine warfare. These were helicopter carriers designed for defensive operations in waters near Soviet territory, not power projection platforms capable of sustained offensive operations far from home waters. The Kiev-class carriers, commissioned beginning in 1975, represented the Soviet Union's first attempt at something approaching a true aircraft carrier. 4 ships of this class were built, displacing approximately 45,000 tons fully loaded. They operated a mix of helicopters and fixed-wing aircraft, specifically the Yak-38 vertical takeoff and landing aircraft. The Yak-38 provided some fixed-wing capability, but its performance limitations were severe. The aircraft had limited range, modest weapons payload, and handling characteristics that made it challenging to operate effectively. Compared to American carrier-based aircraft like the F-14 Tomcat or A-7 Corsair II, the Yak-38 was generations behind in capability. More critically, the Kiev-class carriers used conventional steam turbine propulsion. The power plants burned fuel oil, generating steam to drive turbines connected to the propeller shafts. This conventional propulsion meant the ships had limited range and endurance. The Kiev-class carriers could steam approximately 3,600 nautical miles before requiring refueling. In practice, sustained carrier operations required more fuel consumption than transit steaming, reducing that range further. During active flight operations with the ship maneuvering to provide optimal wind conditions over the flight deck, maintaining position in rough seas, operating at high speed to maximize aircraft launch capability, the Kiev-class carriers required refueling every 2 to 3 weeks. This created an operational constraint that fundamentally limited Soviet carrier effectiveness. The ships required constant support from fleet oilers, tanker vessels carrying fuel oil, to replenish the carriers at sea. This logistics tail was vulnerable to interdiction by enemy submarines or aircraft. More importantly, the requirement to rendezvous with tankers every few weeks dictated operational planning. Soviet carriers couldn't position independently and remain on station for extended periods. They couldn't respond to crises and maintain presence indefinitely. Every operation was measured in weeks before the fuel situation would require either replenishment or return to port. The doctrinal limitations went beyond simple logistics. Soviet naval doctrine had developed during the 1950s and 1960s around fundamentally different priorities than American naval thinking. The United States Navy emphasized power projection and sea control, the ability to dominate ocean areas and project military force ashore from carrier-based aircraft. The Soviet Navy focused on coastal defense and sea denial, preventing American carriers from approaching Soviet territory and threatening the submarine forces that carried Soviet strategic nuclear deterrent. Admiral Sergei Gorshkov, who led the Soviet Navy from 1956 to 1985, pushed for a more offensive blue water navy capable of challenging American sea control. But he faced constant resistance from Soviet leadership and competing priorities for defense resources. The Soviet Union eventually attempted to build true fleet carriers comparable to American supercarriers. The Admiral Kuznetsov, launched in 1985 and commissioned in 1990, represented this ambition. At 67,000 tons displacement, carrying Su-33 fighters and Ka-27 helicopters, the Kuznetsov was a legitimate fleet carrier by international standards. But even this ship, the culmination of Soviet carrier development, remained limited by conventional propulsion. Steam turbines burning fuel oil provided power, creating the same endurance limitations that constrained the Kiev-class ships. The Kuznetsov could operate longer than the Kiev-class carriers due to larger fuel bunkers, but it still required regular refueling to sustain operations. And even at 67,000 tons, it was less than two-thirds the displacement of a Nimitz-Class carrier, carrying roughly half the aircraft complement. Political constraints limited Soviet carrier development throughout the Cold War. Admiral Gorshkov advocated strongly for supercarriers comparable to American vessels. He argued that sea control required carriers, that the Soviet Navy couldn't effectively challenge American naval dominance without equivalent power projection capability. The Kremlin consistently prioritized other capabilities. Submarines, particularly ballistic missile submarines carrying strategic nuclear weapons, received priority funding. Anti-ship missiles, designed to threaten American carriers from aircraft, ships, and submarines, consumed substantial resources. The official Soviet position often stated that aircraft carriers were obsolete targets for Soviet missiles. Yet, simultaneously, the Soviet Union attempted to develop its own carrier fleet, a contradiction that revealed the perceived value of carrier capability despite official rhetoric. Industrial limitations compounded the political and doctrinal constraints. Soviet shipyards, even the largest facilities capable of building major warships, couldn't construct vessels exceeding approximately 70,000 tons. The dry docks, the slipways, the cranes, and the support infrastructure were sized for ships of that displacement. Building a 100,000-ton supercarrier like the Nimitz would require constructing entirely new shipbuilding facilities. The investment was prohibitive, the construction timeline measured in decades. The Soviet Union never made that investment and consequently never built carriers in the Nimitz-Class. Nuclear propulsion represented another insurmountable technological barrier. The Soviet Navy operated nuclear-powered submarines very successfully, developing reliable submarine reactor designs comparable to American systems. But a submarine reactor, designed to power a vessel displacing perhaps 20,000 tons, operating submerged where cooling water is readily available, is fundamentally different from a carrier reactor. Carrier reactors must generate enormous power, providing steam for turbines producing hundreds of thousands of horsepower. They operate in a surface vessel subject to different environmental conditions and safety requirements. The Soviet Union never successfully developed carrier-sized nuclear reactors with sufficient reliability for operational deployment. Programs existed, development work occurred, but no Soviet carrier ever operated with nuclear propulsion throughout the entire Cold War period. The doctrinal contradiction embedded in Soviet naval thinking revealed the fundamental challenge. Official Soviet military theory maintained that aircraft carriers were vulnerable, expensive, and obsolete in the missile age. Soviet anti-ship missiles, particularly weapons like the SS-N-19 shipwreck with its 500-kilometer range and nuclear warhead option, were designed specifically to engage American carrier battle groups. Yet despite this official position that carriers were targets rather than assets, the Soviet Union invested substantial resources attempting to develop its own carrier capability. The contradiction suggested that Soviet naval planners understood the actual value of carriers for power projection, but couldn't acknowledge that understanding without undermining the justification for the anti-carrier missile programs that consumed substantial resources. While the Soviet Union struggled with these constraints, the United States was developing and deploying the Nimitz-Class, a carrier design that would define American naval supremacy for half a century. The design specifications for the Nimitz-Class reflected accumulated American experience operating fleet carriers since World War II. The hull measured 1,092 feet from bow to stern, with a flight deck beam of 252 feet at its widest point. Fully loaded displacement exceeded 100,000 tons, with some ships in the class approaching 110,000 tons as modifications and equipment additions occurred over their service lives. The propulsion system was the revolutionary element that enabled all other capabilities. 2 Westinghouse A4W nuclear reactors provided the power. Each reactor used highly enriched uranium fuel in a pressurized water reactor design. The nuclear reaction heated water in the primary cooling loop to extremely high temperatures, while maintaining it under pressure to prevent boiling. Heat exchangers transferred this thermal energy to a secondary loop of water that was allowed to boil, generating steam. This steam drove 4 massive turbines, each connected through reduction gearing to a propeller shaft. The combined output of the 2 reactors, operating through the 4 turbines, provided 260,000 shaft horsepower, sufficient to drive the enormous hull through the water at speeds exceeding 30 knots. The reactor core life was the transformative capability. Using highly enriched uranium fuel and advanced core designs, the A4W reactors could operate for more than 25 years before requiring refueling. In practice, this meant a Nimitz-class carrier would serve approximately half its planned service life before entering a major overhaul that included reactor refueling and core replacement. The USS Nimitz itself operated from 1975 until 2001 before its first refueling overhaul, 26 years of operations on the original reactor cores. This unlimited range capability changed every calculation about carrier operations. The ship could steam at maximum speed continuously without consuming any fuel that required replenishment from external sources. Transit from the east coast of the United States to the western Pacific, approximately 8,000 nautical miles, required no refueling stops. Operations on station, maneuvering at high speed during flight operations, maintaining position in rough seas, could continue indefinitely. The only constraint was the aviation fuel consumed by the embarked aircraft, the ordnance expended during flight operations, and the food stores required to feed the crew. The flight deck spanned 4.5 acres, providing sufficient space for aircraft parking, maintenance, and simultaneous launch and recovery operations. 4 C-13 steam catapults, positioned at the bow and along the angled flight deck, could launch aircraft at intervals of less than a minute when operating at surge capacity. The system could launch 24 aircraft in 10 minutes during surge operations, an extraordinary capability that enabled rapid force projection. 4 arresting wires, positioned across the landing area of the angled flight deck, provided recovery capability. Aircraft could be launched and recovered simultaneously, with the angled deck design pioneered on earlier American carriers, enabling recovery operations while aircraft were positioned on the bow catapults for launch. The typical aircraft complement included 85 to 90 aircraft and helicopters. The exact composition varied based on mission requirements and the time period, but a standard air wing in the 1980s and 1990s included F-14 Tomcat fighters for fleet air defense and strike missions, F-A-18 Hornet multi-role fighters for air superiority and ground attack, A-6 Intruder all-weather attack aircraft, EA-6B, Prowler electronic warfare aircraft, E-2C, Hawkeye airborne early warning aircraft providing radar surveillance and air control, S-3 Viking anti-submarine warfare aircraft, and SH-60 Seahawk helicopters for anti-submarine operations, search and rescue and logistics support. The crew complement reflected the complexity of operating such a vessel. Ship's company, the personnel responsible for operating the carrier itself rather than the aircraft, numbered approximately 3,200. The embarked air wing added another 2,400 personnel, including pilots, naval flight officers, maintainers, ordnance technicians, and support staff. The total crew of approximately 5,600 made the Nimitz-Class carriers more populous than many small towns. Defensive systems protected the carrier itself. Evolved Sea Sparrow missiles provided point defense against aircraft and missiles that penetrated the outer defensive layers provided by escorting ships and carrier-based fighters. Phalanx close-in weapon system mounts, radar-guided 20mm Gatling guns with high rates of fire, engaged incoming missiles and aircraft in the final seconds before potential impact. Electronic warfare systems detected, analyzed, and attempted to deceive or jam enemy radar and weapons systems. NATO Sea Sparrow launchers and additional defensive systems were added as technology evolved. The carriers themselves were never designed to operate without defensive capability, even though carrier battle group doctrine emphasized that escorts and aircraft would engage threats well before they approached the carrier. Fuel storage capacity for the embarked aircraft was substantial. The Nimitz-class carriers could store approximately 3 million gallons of JP-5 aviation fuel in bunkers distributed throughout the hull. This supported sustained air wing operations for 7 to 10 days of intensive flight operations before requiring replenishment. The nuclear propulsion system freed substantial internal volume that would have been devoted to fuel oil on conventional carriers, allowing that space to be allocated to aviation fuel and ordnance storage instead. Ordnance magazines held more than 2,500 tons of munitions, bombs, missiles, torpedoes, ammunition for aircraft guns, and pyrotechnic devices filled specialized storage areas designed with safety systems to prevent accidental detonation and contain any accidental fires. Elevators moved ordnance from magazines to the flight deck, where ordnance personnel assembled complete weapon loads and transported them to aircraft positioned for arming. The capacity was sufficient for full combat operations, enabling the carrier to conduct sustained strike missions without immediately requiring ammunition replenishment. Construction of Nimitz-class carriers occurred exclusively at Newport News Shipbuilding in Virginia, the only American shipyard capable of building vessels of this size and complexity. The construction process for each ship required approximately 5 years from start to commissioning, involving thousands of workers and millions of hours of labor. The first ship, USS Nimitz, commissioned in 1975. The 10th and final ship of the class, USS George H.W. Bush, commissioned in 2009, 34 years later. This production run created the backbone of American power projection capability for decades. The cost reflected the complexity and capability. The USS Nimitz cost approximately $1 billion in 1970s dollars for construction, equivalent to significantly more in current dollars when adjusted for inflation. The final ships of the class, built in the 2000s, cost more than $8 billion each. The expense was justified by the capability provided, the service life exceeding 50 years, and the strategic value of maintaining continuous global presence through carrier battle groups. The design philosophy emphasized the concept of the carrier as a mobile airbase projecting power globally. American naval doctrine had evolved from World War II experience operating fleet carriers across the Pacific, conducting sustained operations far from home ports, demonstrating that carrier-based air power could control ocean areas and project force ashore. The Nimitz-class represented the ultimate expression of this doctrine, incorporating nuclear propulsion to eliminate the range and endurance constraints that limited earlier carriers. The nuclear propulsion advantages extended beyond the obvious unlimited range capability. Space saved from not requiring fuel oil bunkers could be allocated to storing aviation fuel, ordnance, and spare parts. The ship could carry more of what the aircraft needed to conduct operations, extending the time between underway replenishment operations. Sustained high-speed operations became routine rather than a fuel conservation concern. Conventional carriers often reduce speed to 20 to 25 knots during transit and positioning to conserve fuel oil. Nimitz-Class carriers could maintain 30 knots or higher indefinitely without any fuel consumption concern. This speed advantage enabled faster response to crises, more flexible positioning, and the ability to maintain high speed during flight operations for optimal aircraft launch and recovery conditions. The operational superiority the Nimitz-Class provided became apparent immediately upon deployment of the first ships of the class. Global presence became routine for Nimitz-Class carriers. The ships deployed continuously worldwide, operating in the Mediterranean Sea, Western Pacific, Indian Ocean, Persian Gulf, and other regions where American interests required naval presence. The typical deployment lasted approximately 6 months, during which the carrier and its battle group would operate forward, conducting exercises with Allied forces, providing presence in regions of concern, and maintaining readiness to respond to crises. During these deployments, Nimitz-Class carriers could operate independently of supply ships for weeks at a time. Unlike Soviet carriers that required refueling every 2 to 3 weeks, creating predictable rendezvous points where they were vulnerable, American carriers only required replenishment of aviation fuel, ordnance, spare parts, and food stores. The nuclear propulsion meant the ship itself consumed no fuel that needed replacement. This dramatically reduced the logistics burden and vulnerability associated with underway replenishment operations. The comparison to Soviet carrier operations was stark. Kiev-class carriers required fleet oilers to accompany them on any sustained deployment. Every 2 to 3 weeks, the carrier would need to rendezvous with the oiler, conduct an alongside replenishment operation, transferring thousands of tons of fuel oil, an operation that required several hours of steaming in formation with the tanker, during which the carrier was unable to conduct flight operations effectively and was vulnerable to observation and potential engagement. The logistics train supporting Soviet carrier operations was substantial and exposed. Specific deployments demonstrated the operational advantage nuclear propulsion provided. The USS Nimitz deployment to the Indian Ocean in 1980, responding to the Iran hostage crisis, illustrated the capability. The carrier operated independently for more than 45 days without returning to port, maintaining a continuous presence that no Soviet carrier could match. The ship could respond to changing tactical situations, reposition as required, conduct continuous flight operations, all without the constraint of fuel consumption limiting endurance. The USS Dwight D. Eisenhower, CVN-69, deployed to support operations off Lebanon in 1982, provided air cover and strike capability for 6 months continuously. The nuclear propulsion enabled unrestricted positioning. The carrier could maintain station regardless of weather, sea state, or operational tempo. Soviet carriers operating in the Mediterranean during the same period required regular port visits or extensive oiler support, limiting their operational flexibility and presence. The USS Carl Vinson, CVN-70, conducted operations in 1983 that Soviet naval intelligence monitored closely. The carrier maintained sustained air operations while Soviet observation noted that the Novorossiysk, a Kiev-class carrier operating in adjacent waters, required refueling operations twice weekly. The operational tempo disparity was obvious. American carriers could surge their operations when required without concern about fuel consumption. Soviet carriers operated under constant fuel budgeting, aware that increasing operational tempo would accelerate the time until the next required refueling. Nimitz-class carriers served as flagships for carrier battle groups and larger task forces. The internal volume and power generation capability enabled installation of command centers with the communications equipment, staff facilities, and operational spaces required for battle group commanders and their staffs. This command capability was difficult to replicate on smaller ships that lacked the space and power generation to support extensive command facilities. The speed advantage nuclear propulsion provided had tactical and strategic implications. Conventional carriers often reduce speed to conserve fuel during transit and non-combat operations. Maintaining high speed consumed fuel rapidly, creating trade-offs between speed and endurance. Nimitz-Class carriers had no such constraint. They could maintain 30+ knots indefinitely. This meant faster response to crises, crossing thousands of miles of ocean in less time. It meant better positioning flexibility once on station, able to reposition rapidly to respond to changing tactical situations. It meant optimal flight operations, maintaining high speed into the wind to maximize the effective wind speed over the flight deck, improving aircraft performance during launch and recovery. Soviet naval reconnaissance aircraft regularly photographed American carriers operating at high speed in poor weather conditions. The intelligence analysis recognized that conventional carriers couldn't sustain such operations. The fuel consumption at high speed in rough seas would be prohibitive. American carriers operated unconstrained by fuel considerations, a capability Soviet carriers couldn't match. Crisis response demonstrated another dimension of the operational advantage. When regional crises emerged requiring American military presence, carriers could reposition from other areas and arrive on station within days. Once positioned, they could remain indefinitely. Soviet carriers could respond similarly, but their presence was time-limited. After several weeks, fuel considerations would require either replenishment or departure. American presence was essentially unlimited duration, constrained only by crew endurance and the political decision to maintain the deployment. The training advantage nuclear propulsion enabled shouldn't be underestimated. Unrestricted steaming allowed continuous flight operations during workup periods, before deployments and throughout deployments themselves. American naval aviators flew substantially more hours than their Soviet counterparts. The difference was typically 2 to 3 times more flight hours per pilot per year. This proficiency advantage compounded over careers. American pilots accumulated thousands of hours of carrier operations experience, becoming highly proficient at night operations, adverse weather operations, and combat tactics. Soviet naval aviation, limited by the fuel constraints of their carriers and the smaller number of carriers available, never achieved comparable flight hour accumulation. Maintenance advantages accrued from the long reactor core life. Conventional carriers required regular dry dock periods for hull maintenance, propulsion system maintenance, and general overhaul. Nuclear carriers required similar maintenance, but the nuclear reactor itself could operate for 25 years without requiring the extensive overhaul associated with reactor refueling. This meant higher operational availability, more time deployed, less time in maintenance. The calculation became simple over the service life of the vessel. More availability meant more deployments, more presence, more capability delivered per ship. The total class deployment of 10 carriers provided extraordinary capability. At any given time, multiple Nimitz-Class carriers were deployed forward worldwide. Others were in training workups preparing for deployment. Some were in maintenance. The cycle ensured continuous presence. The Soviet Navy never achieved comparable presence. At maximum capability, the Soviet Union operated 4 Kiev-class carriers and was building the Admiral Kuznetsov. But the constraints on individual carrier operations meant that sustained presence in multiple ocean areas simultaneously was effectively impossible for Soviet carrier forces. The reasons the Soviet Union couldn't compete with American carrier capability were multiple, interrelated, and ultimately insurmountable within the constraints of Soviet technology, economics, and doctrine. Nuclear reactor technology was the fundamental barrier. Soviet engineers had developed excellent submarine reactor designs. The OK-650 reactor, used in Soviet nuclear submarines, was reliable, powerful for its size, and successful operationally. But a submarine reactor generating approximately 50,000 shaft horsepower was fundamentally different from a carrier reactor needing to generate 260,000 shaft horsepower or more. The engineering challenges were substantial. The reactor had to be much larger, generating far more heat, requiring more sophisticated cooling systems, more extensive safety systems, more complex control systems. Soviet engineers worked on carrier reactor designs throughout the 1970s and 1980s, but never achieved a design with sufficient reliability for operational deployment. Shipbuilding capacity limited options, even if reactor technology had been solved. The largest Soviet dry dock capable of building major warships could accommodate vessels up to approximately 60,000 tons displacement. Building a 100,000-ton carrier like the Nimitz required either constructing a new, much larger dry dock or assembling the ship in sections in multiple locations and joining them, a technically challenging approach. The investment required to build the necessary infrastructure was enormous. The Soviet Union considered these investments during the 1980s, but never committed the resources required. The shipbuilding industry was entirely state-controlled and military-focused, without the commercial shipbuilding sector that supported American shipyards and enabled them to maintain capability for building very large vessels. Economic constraints became increasingly binding during the 1980s as the Soviet economy stagnated. A single Nimitz-Class carrier cost more than $1 billion in 1970s construction costs, likely equivalent to significantly more in Soviet rubles when accounting for different economic efficiencies and industrial capabilities. The Soviet defense budget, while large, supported a much broader set of programs than the American defense budget. Soviet strategic nuclear forces required continuous investment. Conventional ground forces, much larger than American forces, consumed substantial resources. The submarine fleet, including ballistic missile submarines, critical to strategic deterrence, and attack submarines designed to counter American carriers, was a priority. Air defense systems, both strategic and tactical, required investment. Anti-ship missile programs consumed research and procurement budgets. Within these constraints, funding a carrier program comparable to American capability would require either substantial increase in total defense spending or dramatic reallocation from other priorities. Neither occurred. Doctrinal inertia created institutional resistance to carrier investment. The Soviet Navy had developed doctrine around submarines and anti-ship missiles over decades. Senior officers had built careers within this doctrinal framework. Entire design bureaus, research institutes, and industrial facilities existed to support submarine and missile programs. Admitting that carriers were necessary and valuable undermined the justification for these existing programs. The cognitive dissonance was substantial. Official statements emphasized that carriers were vulnerable, expensive, and obsolete. Yet simultaneously, the Navy attempted to develop carrier capability. The contradiction created internal political challenges that complicated resource allocation decisions. Political priorities reflected ideological concerns as well as practical considerations. Aircraft carriers were symbols of American imperialism in Soviet political rhetoric. Large carriers represented power projection, the ability to intervene militarily in regions far from home territory. Soviet ideology emphasized defensive purposes for military forces, protecting socialism rather than projecting power offensively. Admitting that the Soviet Union needed carriers comparable to American vessels implied accepting that power projection was necessary, contradicting decades of ideological positioning. The political leadership was reluctant to fully embrace carrier development despite military arguments for the capability. The industrial ecosystem supporting American carrier construction had no Soviet equivalent. American commercial shipbuilding, while smaller than in earlier decades, maintained capabilities that transferred to military construction. The nuclear power industry, with dozens of commercial power reactors operating and extensive research and development infrastructure, provided technological foundations that naval reactor programs could leverage. Soviet industry was entirely state-controlled and military-focused. Commercial applications were minimal. The technology transfer between civilian and military nuclear programs was more limited. The shipbuilding sector worked exclusively on military and state commercial vessels, without the diverse experience base American yards maintained. Training pipelines presented another challenge. The United States Navy had trained carrier crews continuously since World War II. Multiple generations of officers and sailors had gained experience operating carriers, developing tactics, refining procedures, and accumulating institutional knowledge. This expertise was embedded throughout the service. Soviet naval aviation was newer, smaller, and less experienced. Starting from essentially zero in the mid-1970s with the Kiev-class carriers, Soviet naval aviation had to develop capabilities that American naval aviation had refined over decades. The learning curve was steep, the institutional knowledge was lacking, and the experience gap was enormous. Operational experience compounded every other disadvantage. American carriers had operated continuously in combat and peacetime operations since World War II. From the Pacific campaigns of 1944 and 1945 through Korea, Vietnam, numerous smaller operations, continuous forward deployments and exercises, American carrier forces had accumulated more than 30 years of continuous operational experience by the time the first Nimitz-Class carrier commissioned. The Soviet Union commissioned its first aircraft carrier in 1967, the helicopter carrier Moskva. The first carrier operating fixed-wing aircraft, the Kiev, commissioned in 1975. Even by 1990, Soviet carrier operational experience spanned only 15 years with very limited platforms. The experiential gap was unbridgeable within any reasonable time frame. The strategic dominance the Nimitz-class carriers provided shaped global security for decades and continues to influence geopolitics in 2025, 50 years after the first ship of the class commissioned. 10 Nimitz-class carriers gave the United States unprecedented power projection capability. At any given time, throughout the Cold War and post-Cold War periods, multiple carriers were deployed forward in regions of concern. The Mediterranean typically hosted at least one carrier. The Western Pacific and Indian Ocean usually had 2 carriers forward. Additional carriers could surge to regions during crises. The presence was continuous, the capability was overwhelming, and no other nation possessed remotely comparable ability to project air power globally from mobile platforms. Soviet attempts to counter this capability focused on anti-ship missiles rather than matching carrier capabilities. The massive SS-N-19 shipwreck missiles deployed on Soviet cruisers and submarines could theoretically threaten American carriers, but actually employing these systems required finding the carriers penetrating their defensive screens and achieving hits against defended targets supported by sophisticated electronic warfare and air defense systems. The Soviets never demonstrated the ability to effectively target and engage American carrier battle groups in realistic scenarios. The Soviet response in carrier development culminated with the Admiral Kuznetsov, commissioned in 1990 as the Soviet Union was collapsing. The ship proved what Soviet naval planners had feared. A conventionally powered carrier, even a relatively large one at 67,000 tons, couldn't match the operational flexibility and sustained presence of nuclear-powered American carriers. The Kuznetsov required regular refueling, limiting independent operations. It carried approximately half the aircraft complement of a Nimitz-class carrier, reducing striking power. After the Soviet collapse, the Russian Federation inherited the Kuznetsov as its only aircraft carrier. As of 2025, Russia operates this single carrier, and it spends more time in maintenance than deployed. The limitations Soviet planners identified in the 1970s and 1980s remain evident decades later. The modern impact of the Nimitz-class is demonstrated by their continued operation in 2025, 50 years after the first ship commissioned. The USS Nimitz itself, CVN-68, is scheduled for decommissioning in the mid-2020s after approximately 50 years of service. Other ships of the class will continue operating into the 2040s and possibly 2050s. This longevity testifies to the soundness of the nuclear propulsion concept and the robust nature of the design. The ships have been extensively modernized over their service lives, receiving updated aircraft, weapons systems, sensors, and communications equipment. But the basic platform, the nuclear-powered hull and flight deck, remains viable decades after construction. The Ford-class carriers now entering service represent the successor to the Nimitz-class, incorporating lessons learned from 5 decades of nuclear carrier operations. The Ford-class continues the nuclear propulsion model, with upgraded reactors providing even more electrical power for advanced systems. Enhanced flight deck design and electromagnetic catapults improve aircraft launch capacity. The fundamental concept remains unchanged, a nuclear-powered supercarrier projecting power globally with essentially unlimited endurance. The geopolitical leverage. American carrier presence shapes regional conflicts and deterrence calculations. When crises emerge, American leaders ask where the nearest carrier is positioned. The ability to move mobile air power to any ocean region within days, then maintain presence indefinitely, provides options that no other form of military power can match. Nations without carrier capability cannot contest American naval presence effectively. Even nations with advanced military capabilities generally lack the ability to threaten carrier battle groups effectively when they operate with competent defensive tactics. China's development of an aircraft carrier program in the 21st century demonstrates the continued relevance of carrier capability. Chinese carriers remain conventionally powered, facing the same endurance limitations Soviet carriers encountered. China is reportedly developing nuclear carrier designs, recognizing that matching American capability requires solving the same nuclear propulsion challenges the Soviet Union failed to overcome. The technical difficulty remains substantial even with modern technology. October 3, 1975. The USS Nimitz steamed out of Norfolk Harbor on its initial sea trials. The massive hull, displacing over 100,000 tons, moved through the water at speeds exceeding 30 knots, driven by nuclear reactors that would power the ship for more than a quarter century before requiring refueling. The ship would operate for 50 years, deploying to conflicts and crises across the globe, projecting American power in ways Soviet naval planners could never match. The Soviet Navy had designed forces to deny the seas to American carriers, to threaten them with submarines and missiles, to contest sea control through asymmetric means. It was a doctrine born of necessity, acknowledging that the Soviet Union couldn't match American carrier capability directly. America had built floating cities that owned the seas for half a century. 10 Nimitz-Class carriers, each one a 4.5-acre piece of sovereign American territory, carrying 90 aircraft, powered by reactors that never needed refueling during their operational lives, deployed continuously worldwide throughout the Cold War and beyond. The Soviet Union built 4 Kiev-class carriers with conventional propulsion that required refueling every few weeks. They built one fleet carrier, the Admiral Kuznetsov, that commissioned as the Soviet Union was collapsing. They never deployed a nuclear-powered carrier. The gap wasn't subtle. It was decisive. And it demonstrated that some technological and industrial challenges couldn't be overcome through determination or alternative approaches. Nuclear carrier capability required decades of accumulated experience, massive industrial infrastructure, sustained investment, and technical expertise across multiple domains. The Soviet Union, despite being a superpower with vast resources and technological achievements in other areas, never matched American carrier capability. The Nimitz-class carriers demonstrated that nuclear propulsion didn't just provide unlimited range. It provided operational flexibility, sustained presence, crisis response capability, and power projection that defined American naval supremacy for 50 years. As the first ships of the class approach retirement and Ford-class successors enter service, the fundamental lesson remains unchanged. Nuclear power changed naval warfare permanently, and the nation that mastered it first developed it most completely, and deployed it most extensively gained advantages that persisted for half a century and continue today. The Soviet Navy designed a force to deny the seas to American carriers. They never succeeded. Because denying the seas to platforms that could operate anywhere indefinitely without refueling proved impossible with the technology and resources available to them. America built carriers that could steam for decades without refueling. The Soviet Union never matched that capability, and that difference shaped the balance of naval power throughout the Cold War and beyond.